Hello Geometry class, it's March 23rd, 2020. We're going to go over lesson 10.1 samples. So in sample 1, we are told that D is a point of tangency, and from that we're to figure out what is R. Because we know that D is a point of tangency, then we know it's also true that angle D must be a right angle. That means that we have a right triangle with sides 12R and 6 plus R. So we're going to go ahead and use the Pythagorean theorem to figure out the measurement of our unknown radius. So we're going to take those legs, 12 and R, and we're going to square them and add them, and we're going to know that that is in fact equal to R plus 6 quantity squared. So that hypotenuse over here, that 6 and R together makes the hypotenuse. We do have to add those two measurements together to get the length of the entire hypotenuse. We then go ahead and simplify our equation. 12 squared is 144. And to figure out our R plus 6 quantity squared, again, remember we're going to use the FOIL process that we learned in Algebra 1 class. R plus 6 times R plus 6 gives us R squared plus 12R plus 36. We then subtract R squared from both sides of the equation, and then we have a very simple linear equation to solve. Subtract 36 on both sides, and 108 is equal to 12R. Divide by both sides by 12, and R is equal to 9. And that was our goal, to find the measurement of the radius, which we did using the Pythagorean theorem on the right triangle formed because D is a point of tangency on circle C. Now we're going to take a look at sample 2. In sample 2, we are asking the question, is line segment AB tangent to circle C? And then to show how you know. Well, if in fact line segment AB is tangent to circle C, then we would be able to use the Pythagorean theorem once again to show that the possible legs, 5 and 8, when we square them and add them, would be equal to the possible hypotenuse of 13 squared. So we set up 5 squared plus 8 squared and ask, is that equal to 13 squared? Simplifying that, we have 25 plus 64, is that equal to 169? Adding the 25 plus 64, we get 89, and we're asking, is 89 equal to 169? And no way, that is way far apart. So no, the line segment AB is not tangent to circle C. I drew it to kind of mislead you in a certain sense, to make you think that in fact that was a right triangle, but clearly it's not, since the Pythagorean theorem does not work for these possible sides and possible hypotenuse. Last sample, sample 3. So on sample 3, we have a circle with 2 tangent line segments. We know those are tangent line segments that meet at a point external to the circle because of the right angles marked in next to the radius and those tangent lines. So when we notice that we have those tangent lines that proceed from the circle to a point external to the circle, we know those tangent lines must in fact be congruent. So to figure out the measurement of x, or figure out the value of x, all we have to do is set 2x plus 8 equal to 5x minus 10 and solve that equation. It's a simple linear equation to solve. We will first subtract 2x on both sides and arrive at 18 is equal to 3x. Then divide both sides by 3, and voila, x is equal to 8, and we're done. So that completes our 10.1 samples. Please review these notes, make sure they're in your lesson work, make sure that your lesson is turned in with your guided practice and your homework problems and these samples, and then proceed to the quiz assignment. We'll see you next time.